High voltage and high power are the way forward for automotive electronics, but guess what? Global standards can't keep up with how fast the technology is moving. 800-volt systems are already becoming the norm, and some companies have even rolled out 1200-volt GaN power chips. But as the voltage and power go up, so do the challenges with reliability. That's where wide bandgap materials come in. They're game changers thanks to their high voltage tolerance, low losses, and thermal stability. They're becoming a must-have for automotive power devices. However, the current international standards, such as AEC Q101, do not fully address the unique characteristics of WBG devices. So here's the big question: how do we make sure our products are reliable, even before the standards catch up? Welcome to iST Tech Express, designed to bring you up-to-date tech news quickly. The application of wide bandgap semiconductors in automotive electronics is growing rapidly. However, mainstream reliability verification methods still follow silicon-based standards such as AEC Q101, AQG 324, and ISO 16750. This creates a gap between technology development and testing regulations, which often leaves engineers facing two key challenges. 1. International standards like AEC Q101 don't yet fully reflect WBG device characteristics. 2. Traditional test equipment struggles to meet the demands of high-voltage, high-power WBG devices. While international standards are evolving, our extensive experience in customer validation has enabled us to develop reliability testing solutions tailored for WBG semiconductors. Take AEC Q101, one of the key automotive electronics validation standards established by the Automotive Electronics Council, as an example. The current test specifications do not yet fully address the unique requirements of WBG semiconductors. At the 2024 AEC Members Workshop in Detroit, 7 potential updates for WBG testing were discussed. Here are 3 key test items highlighted during the workshop. 1. HVH3TRB removes the traditional 100-volt limit, allowing test conditions to better reflect real-world high-voltage applications. 2. IOL uses self-heating to simulate high/low temperature cycles, evaluating the switching endurance of the device. 3. PCT, designed for high-power modules, this test allows real-time monitoring of delta TJ, Tgmax, and thermal resistance variation. In addition to the 3 methods above, TC, GSS, VDOL, and HAS/H3TRB are also under consideration as part of future AEC Q101 updates to address the specific demands of WBG semiconductors. On the other hand, upgrading test equipment is equally critical. Traditional setups were primarily designed for testing silicon-based ICs, but as WBG semiconductors continue to push the limits of power and voltage, these legacy systems are no longer sufficient to meet modern testing demands. To tackle these challenges, test laboratories must be equipped with the right environment and appropriate test conditions to ensure accurate and reliable results. Here are 3 key requirements to meet WBG testing needs. 1. High power and high voltage testing capability, equipped with multiple high-temperature test systems reaching up to 350 degrees Celsius, along with a nitrogen supply system to prevent oxidation in high-temperature environments, ideal for SiC and GaN testing. 2. Comprehensive testing solutions. For automotive standards like AEC Q101 and AQG 324, we offer flexible and comprehensive solutions that overcome the limitations of single equipment setups and ensure full test coverage. 3. Real-time parameter monitoring and simulation testing. Through pre-simulation testing, we ensure product reliability during both assembly and testing, minimizing the risk of failure and improving development efficiency. As electric vehicles and high-power applications continue to evolve, reliability validation for WBG semiconductors is becoming increasingly important. We'll continue to monitor changes in international standards and delivering advanced testing technologies to help you stay ahead of new challenges. Want to learn more? Click the info section to check out our iST Classroom technical article for a deep dive into the details, or reach out to us for a chat. And don't forget to subscribe to the iST channel to stay updated on the latest industry news. This is iST Tech Express. See you next time. Bye.